Good morning, students. So, in today's class, let us continue with the previous year questions solved from the D and F block elements chapter. The first question will be having a transition metal ion exists in its highest oxidation state. It is expected to behave as. So, whatever we have the D block elements which are exist in a highest oxidation states. Okay, so they'll show the common oxidation states as well as the highest oxidation states as well, so that it is expected to behave as. So ಯಾವ ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ಸು ಹೈಯೆಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟನ್ನು ತೋರಿಸುತ್ತೆ, ಸೊ ಅದು ಯಾವ ರೀತಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ ಇನ್ ನೇಚರಲ್ಲಿ ಅನ್ನೋದನ್ನ ವಿ ಶುಡ್ ನೋ. ಸೊ ದ ಫಸ್ಟ್ ಆಪ್ಷನ್ ವಿ ಹ್ಯಾವ್ ಎ chelating agent. Second option will be having a central metal in a coordination compound, and third option we have an oxidizing agent, and fourth option we have a reducing agent. Okay, so here when the transition metal ion exists in its highest oxidation state, it acts as a oxidizing agent. Okay, so the point is, so when the transition metal which shows the highest oxidation state means what? So it is acting as a oxidizing agent agi act ಮಾಡ್ತಿರುತ್ತೆ. Oxidizing agent. For example, if I consider an example, manganese plus 6. So manganese 6 in KMnO4. KMnO4 ಅಲ್ಲಿ manganese will be having the oxidation number plus 6 ಇರುತ್ತೆ. Okay, so in this where MnO4 2 minus will be acts as what? Strong oxidizing agent ಆಗಿ ನಮಗೆ act ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳ್ಬೋದು. See the options we have, the first one is a chelating agent, second option is a central metal in a coordination compound, third option is an oxidizing agent, third option is a reducing agent. So that we can choose option third, that is an oxidizing agent is the right answer. ಯಾಕೆ ಅಂತ ಅಂದ್ರೆ, ಸೊ ಯಾವ ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ ಹೈಯೆಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ನ ಹೊಂದಿರುತ್ತೆ, ಸೊ ಆ ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ ವಿಲ್ ಬಿ ಆಕ್ಟಿಂಗ್ ಆಸ್ ವಾಟ್? ಸ್ಟ್ರಾಂಗ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಸೊ ಫಾರ್ that reason we can choose option 3 is the right answer. Then next question we have, the formula mass of more salt is 392. The iron present in its oxidized state by KMnO4 in acid medium, the equivalent mass of more salt is. So the formula mass, molecular mass of more salt is to the 392 they have given. 392 is the molecular mass of what? Ferrous sulfate. Ferrous ammonium sulfate, more salt. The iron present in its molecular mass, that is oxidized by the KMnO4. So in acidic medium, the equivalent mass of more salt ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ more salt ಅಂತ ಅಂದ್ರೆ, so that is FAS. So FAS we call it as more salt. So that is ferrous ammonium sulfate. Ferrous ammonium sulfate ನ ಏನಂತ ಹೇಳ್ತೀವಿ? more salt ಅಂತ ಹೇಳ್ತೀವಿ. Ammonium sulfate we call it as what? More salt. So if we write the formula, no, so we'll be having NH4 twice SO4 FeSO4 into 6 water. So this is FAS, ferrous ammonium sulfate. Okay, so ಇಲ್ಲಿ ಐರನ್ದು they are asking the equivalent mass of more salt ಎಷ್ಟಾಗಿರುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. So the iron present in its more salt is, so iron, that is Fe2 plus, 5 moles of Fe2 plus is combined with the MnO4 minus, that is oxidizing agent, which acts as a oxidizing agent, plus it is taking place in the presence of acidic medium, that is 8 plus H plus, it is going to give 5 Fe3 plus Mn2 plus Mn2 plus 4 moles of water is going to form. So ಇಲ್ಲಿ oxidation number change ಏನಾಗುತ್ತೆ? The change in oxidation number of iron is, change in oxidation number of iron is, that is equals to plus 3 -2. ಸೊ ಈಗ ಐರನ್ ನಮಗೆ +3 ಫಾರ್ಮಲ್ಲೂ ಇರುತ್ತೆ, +2 ಫಾರ್ಮಲ್ಲೂ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಇಫ್ ವಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ದ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಆಫ್ ಐರನ್ನು, ಸೊ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ವಾಟ್. ಸೊ ಇಲ್ಲಿ ನೋಡಿ Fe2+ ಇಂದ Fe3+ಗೆ ಆಕ್ಸಿಡೈಸ್ ಆಗಿದೆ. ಇನ್ಕ್ರೀಸ್ ಇನ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್, ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಆಕ್ಸಿಡೇಷನ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್. ಓಕೆ, ಸೊ +3 minus +2 is will becomes what? +1. Okay, so that here then equivalent weight of more salt, equivalent weight of more salt, that is FAS, is equals to molecular weight of FAS divided by 1. So where 1 is the change in oxidation number of the iron, so that is 1. So that is equals to, if we do 392 divided by 1, so that is equals to 392. Okay, so ಈಗ in the presence of KMnO4O, more salt undergo oxidation in acidic medium ಆದಾಗ iron will changes its oxidation number from Fe2+ to Fe3+. ಆಗ is there any changes in equivalent mass ಅಂತ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ will be getting the equivalent weight of the ferrous ammonium sulfate will be same only. So will be having the value is what? 392 ನಮಗೆ again equivalent mass ಸಿಗುತ್ತೆ. ಸೊ ದಟ್ ಆಪ್ಷನ್ 1 ಏನಿದೆ ದಟ್ ಇಸ್ 392. ಆಪ್ಷನ್ 1 ಇಸ್ ದ ರೈಟ್ ಆನ್ಸರ್. Okay, so then next we'll move on to the next question, that is formation of colored solution is possible when metal ion in the compound contain. So when the colored solution is possible when metal ion is having which options they are asking. So the first option we have lone pair of electrons, second one is unpaired electrons, third one is paired electrons, and none of these they are giving. So ಈಗ ಒಂದು like any of the solutions are colored pair ಆಗ್ತಿದೆ ಅಂತ ಅಂದ್ರೆ because of the presence of transition metals. So in that solution, if any transition metallic ions are there, so that particular solution will show color. Okay, so ಈಗ for the formation of colored solution, metal ion in the compound should contain unpaired electrons. ಸೊ ಮೆಟಲ್ ಅಯಾನು ನಮಗೆ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಹೊಂದಿದ್ರೆ so that colored solution, that solution will show the color ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಓಕೆ, ಸೊ initially the solution will the few solutions are showing color because of the presence of unpaired electrons and also presence of transition metals irutte. So our transition metals alli if we observe the configuration, so there is a presence of unpaired electrons in that, so that solution will become colored. Okay, so that we can say that unpaired electrons are the right answer. Okay, and also whatever the colored solutions are there, no? So ಈಗ initially without colored solutions what happens, it will observe the UV light. So UV light ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿಕೊಂಡು, okay, so whatever the electrons are present in a D are present in that solution, no? That electrons are shift to from ground state to the excited state ಗೆ shift ಆದಾಗ ಅಲ್ಲಿ while coming back to the ground state, so there they will absorb some light from UV visible region and they'll give complementary colors as well. So all this happened just because of the presence of unpaired electrons. Okay, so that option 2 is the right answer. Next question, which of the following forms a colorless solution in aqueous medium? So ಕೊಟ್ಟಿರೋಂಥದ್ರಲ್ಲಿ ಯಾವುದು ನಮಗೆ ಕಲರ್ಲೆಸ್ ಸೊಲ್ಯೂಷನ್ ಅನ್ನ ಫಾರ್ಮೇಶನ್ ಮಾಡುತ್ತೆ ಇನ್ aqueous medium ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ದ ಫಸ್ಟ್ ಆಪ್ಷನ್ ವಿ ಹ್ಯಾವ್ Cr+3, ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ Vanadium+3, ಥರ್ಡ್ ಆಪ್ಷನ್ Scandium+3, fourth option is Titanium+3. So now let us write the last valence shell electronic configuration. Chromium+3 will be having 3d3 4s0. Vanadium+3 will be having 3d2 4s0. Scandium will be having 3d0 4s0. and titanium 3 plus will be having 3d1 4s0. ಓಕೆ, ಸೊ ಈಗ ಇದರಲ್ಲಿ ನಾವು ಮಾಲಿಕ್ಯುಲರ್ ಆರ್ಬಿಟಲ್ಸ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದಾಗ ಡಿ ಆರ್ಬಿಟಲ್ಸ್ ಅಲ್ಲಿ ವಿಲ್ ಹ್ಯಾವ್ 3 electrons ಅಲ್ವಾ. ಸೊ ದೆರ್ ಈಸ್ ಎ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ 3 unpaired electrons. ಸೊ ಇನ್ ದಿಸ್ ದೆರ್ ಈಸ್ ಎ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ 2 unpaired electrons. Okay, 1 2, and next will be having there is no unpaired electrons are present in d orbitals, so empty irutte, and here will be having what, 1 electron. Okay na, 1 electron present irodunna nodbodu. So illi scandium alli there is no electrons, but in remaining other options there is a presence of 2 1 or 3 like that unpaired electrons are present. Okay, so actually scandium, so that because of the presence of unpaired electrons they can able to show the color. But which one is colorless andre scandium is the colorless. Okay, so scandium plus 3 is colorless solution. Colorless solution in aqueous medium, as it does not possess any unpaired electron. Okay, so this is the reason the scandium why it is not giving the color solution means there is no presence of unpaired electron in the valence shell. But if we come to other options, there is a presence of the unpaired electrons in the d orbital, so that elements can show what the coloring property we can say. Okay, so now option 3, that is scandium plus 3 will be the right answer. Okay, next we'll move on to the next question. Mercury is a liquid metal because, so ಈಗ mercury liquid metal ಆಗಿರುತ್ತೆ ಯಾಕೆ ಅಂತ ಅಂದ್ರೆ option 1 we have it has a completely filled d orbital that prevents dd overlapping of orbitals. Second option, it has a completely filled d orbital that causes dd overlapping. Third option, it has a completely filled s orbitals. Option fourth is it has a small atomic size. Okay, so actually mercury is a silvery white heavy liquid. So mercury is silvery white heavy liquid, so which is having the specific gravity that is 13.6 irutte, and it has completely filled d orbitals. Presence of what? Completely filled d orbital, so which that prevent dd overlapping of orbitals. Okay na, so according to this explanation we can give option A is the right answer. Okay, because it has a completely filled d orbital irutte, and that prevents what, dd overlapping of orbitals, so that we can choose option 1 is the right answer. So ಇಲ್ಲಿ mercury it is a liquid metal ಯಾಕೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ, because so actually ನೋಡೋದಕ್ಕೆ mercury it looks like a silvery white heavy liquid, and it is having the specific gravity value 13.6 irutte, and completely filled d orbitals irutte that prevent dd overlapping of orbitals. So option 1 is the right answer. Next option, when sulfur dioxide passes in an acidified potassium dichromate solution, that oxidation state of sulfur is changed from. So when sulfur dioxide passes in an acidified potassium dichromate solution, that oxidation state of sulfur is changed from. See, when potassium dichromate acts as a strong oxidizing agent. So it is what? Strong oxidizing agent. It oxidizes other compounds. So ಇದೇನು ಮಾಡುತ್ತೆ, ಇನ್ನೊಂದು ಕಾಂಪೌಂಡ್ಸನ್ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡುತ್ತೆ and gets itself reduced. So another compoundsನ್ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡಿ ಮತ್ತೆ ತನ್ನಷ್ಟಕ್ಕೆ ತಾನೇ ಏನಾಗುತ್ತೆ, ರೆಡ್ಯೂಸ್ ಆಗುವಂಥ ಕೇಪಬಿಲಿಟಿ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ ಮತ್ತು ಸಲ್ಫರು, ಇಟ್ ಈಸ್ ಇನ್ +4 ಸ್ಟೇಟಲ್ಲಿದ್ದರೆ ಆ್ಯಂಡ್ ಇಟ್ ಆಕ್ಸಿಡೈಸ್ ಆದಾಗ +4 ಆ್ಯಂಡ್ ಇಟ್ gets oxidized to +6 ಸ್ಟೇಟ್. ಸೊ ಫಸ್ಟ್ ಏನು ಮಾಡುತ್ತೆ, +6 ಸ್ಟೇಟ್ಗೆ ಆಕ್ಸಿಡೈಸ್ ಆಗಿಬಿಟ್ಟು ವಿಚ್ ಮ್ಯಾಕ್ಸಿಮಮ್ +4 ಸ್ಟೇಟಿಂದ ಏನಾಗುತ್ತೆ, +6ಗೆ ಆಕ್ಸಿಡೈಸ್ ಆಗುತ್ತೆ. ಓಕೆನಾ, ಸೊ ಫ್ರಮ್ +4 ಟು +6ಗೆ ಆಕ್ಸಿಡೈಸ್ ಆಗಿಬಿಟ್ಟು ಆ್ಯಂಡ್ ವಿಚ್ ಈಸ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಆಫ್ ದ ಸಲ್ಫರ್ ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಸೊ ಹಿಯರ್ ಇಫ್ ಐ ಕನ್ಸಿಡರ್ ದ ಓವರಾಲ್ ರಿಯಾಕ್ಷನ್ ವಿತ್ ದ potassium dichromate, no, so I will write when K2Cr2O7 is treated with the 4 moles of sulfuric acid H2SO4, it is going to give K2SO4 plus chromium sulfate SO4 tries plus 7 water plus 3 moles of S. Okay, sulfur. So and again sulfur dioxide when undergo oxidation in the presence of aqueous medium, it is going to give H2SO4. Okay, so when we multiply this with a 3, then the reaction gets balanced. Then here we can write K2Cr2O7 plus H2SO4 plus 3 moles of sulfur dioxide is going to give K2SO4 plus Cr2SO4 tries plus water molecule. Okay, so potassium dichromate, sulfuric acid, sulfur dioxide and potassium sulfate, chromium sulfate and water is going to form. Okay, so ಈಗ ಇದರಲ್ಲಿ if we calculate the ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟು, ಸೊ ನಮಗೆ ಈ ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡಲ್ಲಿ ಇಲ್ಲಿ +4 ಇರುತ್ತೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟು. ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ವರ್ಟ್ ಇನ್ ಟು ದ +6ಗೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟು ಚೇಂಜ್ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ವಿಚ್ ಈಸ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಇಫ್ ಯು ವಾಂಟ್ ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಆಫ್ SO2 and H2SO4. ಸೊ ದಟ್ we can write the answer option 1. So +4 to +6 ಚೇಂಜ್ ಆಗ್ತಿರೋದ್ರಿಂದ we can choose option 1 is the right answer. Next question, which of the following has the maximum number of unpaired d electrons? ಸೊ ಕೊಟ್ಟಿರುವಂಥ ಆಪ್ಷನ್ಸಲ್ಲಿ ಯಾವುದು ಮ್ಯಾಕ್ಸಿಮಮ್ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಹೊಂದಿರುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಫಸ್ಟ್ ಒನ್ Ni+3, ಸೆಕೆಂಡ್ ಒನ್ Cu+, ದೆನ್ zinc 2+, ದೆನ್ iron 2+ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಫಸ್ಟ್ ಒನ್, ಇಫ್ ಐ ರೈಟ್ ದ ಕಾನ್ಫಿಗರೇಷನ್ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ 1s2 2s2 2p6 3s2 3p6 4s0 3d7 ಬರುತ್ತೆ. ಓಕೆನಾ, ಸೊ ದ್ಯಾಟ್ and if we write the d molecular orbital representation, so in d orbital there is a presence of 7 electrons, so 1 2 3 4 5 then 6 and 7. This is the representation. There is a presence of n is equals to 3, number of unpaired electrons will be 3. Okay, so then if I write the configuration for Cu+2, so we'll be having, so up to here we can write argon. Okay, argon last valence configuration is 4s0 3d10. Okay, if I write the molecular representation, d orbital 1 2 3 4 5, so 10 electrons are there. So n is equals to 10 electrons. Okay, so then next we have Zn2+, so we'll be having argon 4s0 3d10. Again we'll be getting what? Same completely filled orbitals, so 10 electrons. N is equals to 10. Then next we have what? Fe2+, so which is having the configuration argon 4s0 3d6. Okay, so if I fill the electrons in this 1 2, 3, 4, 5 and 6. N is equals to 4 unpaired electrons present irutte. Okay, so which of the following has the maximum number of unpaired d electrons anta andre, so ಇಲ್ಲಿ n is equals to completely filled, no, 0, and here also 0. So maximum number of unpaired electrons will be present in a Fe2 plus ಆಗಿರೋದ್ರಿಂದ we can choose, so Fe2 plus is the right answer. Next question. The incorrect statement in respect of chromyl chloride test is: option 1, formation of lead chromate; option B, formation of chromyl chloride; option C, liberation of chlorine; and option D, formation of red vapors. So actually chromyl chloride test is used in a qualitative analysis in order to find out the anions, okay, which are present in the second group. So that is chromyl chloride test. Chromyl chloride test. This test is used to confirm the chloride. Okay, so chloride ion present in the given inorganic salt. Okay, so ಈಗ for example, so how to do this chromyl chloride test andre, first what we have to do, we should take salt, okay, which for which salt we are going to identify, so that a small pinch of salt we should take. For that we should add a solid potassium dichromate, okay, and we should add concentrated H2SO4 for this. Okay, so when we add concentrated H2SO4 for this, we'll be getting the observation like orange red vapors are evolved. Okay, so then when we pass this orange red vapors into the into the another test tube which contains NaOH solution or sodium NaOH or water, so we'll be getting yellow solution barutte. So then for that yellow solution, if we add acetic acid and lead acetate, acetic acid plus lead acetate, so we'll be getting the product LOPPT. Okay na, so namge product LOPPT bandre, so that confirms there is a presence of chloride in that compound. Okay, so illi let us consider, when a small amount of a substance is heated with a concentrated H2SO4 in presence of solid potassium dichromate, deep red vapors barutte, that is orange red vapors are going to form. And if we come to the reactions, no, when sodium chloride salt ge ನಾವು H2SO4 ಅನ್ನು add ಮಾಡಿದ್ರೆ, so it is going to form bisulfite, NaHSO4 plus HCl is going to form. Then again we have potassium dichromate, K2Cr2O7 plus sulfuric acid. What are the reactions will takes place in that test tube anta? So that is potassium bisulfite, KHSO4 plus 2 moles of CrO3 will be getting plus water. Okay, so this is first reaction and this is second reaction will takes place. Then next we'll be getting, when CrO3 is treated with the 2 moles of HCl, will be getting CrO2Cl2 plus water, so which is called as chromyl chloride. Okay, chromyl chloride is going to form. Then again when we treat chromyl chloride, so that is yellow solution with the NaOH, so that is CrO2Cl2 plus NaOH, 4 moles of NaOH. Okay, so we'll be getting the product yellow solution, that is Na2CrO4. Okay, so then again if we add the for Na2CrO4 sodium chromate ge ಮತ್ತೆ ನಾವು when we add acetic acid and lead acetate, okay, so that is PbCH3COO twice lead acetate ಮತ್ತೆ lead acetate and acetic acid add ಮಾಡಿದಾಗ will be getting LOPPT. So LOPPT, so that is PbCrO4. Okay na, so this is LOPPT. So this is the reaction. So then for this what is the answer anta andre, namge finally chlorine liberate agutte. So chlorine is going to liberate. So liberation of chlorine. Option 3 is the right answer. Sorry, the incorrect statement in respect of chromyl chloride test is what ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಇನ್ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಸ್ ದ ಲಿಬರೇಷನ್ ಆಫ್ ಕ್ಲೋರಿನ್ ಏನಿದೆ ದಟ್ ಪ್ರೋಸೆಸ್ ವಿಲ್ ನಾಟ್ ಹ್ಯಾಪನ್ ವೈಲ್ ಡೂಯಿಂಗ್ ದ ಕ್ರೋಮೈಲ್ ಕ್ಲೋರೈಡ್ ಟೆಸ್ಟ್. ನೋಡಿ ಆಪ್ಷನ್ 1 ಅಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಲೆಡ್ ಕ್ರೋಮೇಟ್. ಎಸ್ ಅಫ್ ಕೋರ್ಸ್ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಫಾರ್ಮ್ ಆಸ್ ಎ LOPPT ಫಾರ್ಮಲ್ ಬರುತ್ತೆ. ದೆನ್ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಕ್ರೋಮೈಲ್ ಕ್ಲೋರೈಡ್ ಇನ್ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ವಾಟ್ chromyl chloride. Then formation of red vapors in first step will be getting what orange red vapors barutte when we add sulfuric acid to the salt along with the potassium dichromate. So the option 3 what we have a liberation of chlorine, this will not happen while doing the chromyl chloride test. Next question. The magnetic moment of a transition metal ion is √15 Bohr magneton. Therefore, the number of unpaired electrons present in it is 4, 1, 2, 3 options we have. See, we know the formula magnetic moment is equals to square root of n into n plus 2. So, where n is the number of unpaired electrons. So where our already ನಮಗೆ mu is equals to 15 ಅಂತ ಕೊಟ್ಟಿರೋದ್ರಿಂದ what is n ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. So n we need to calculate. Okay, so ಈಗ when we √15 is equals to mu is already given, so that √15 is equals to square root of n into n plus 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Okay, so that ಈಗ square gets cancelled. Then in next step 15 is equals to n into n plus 2 will be getting. So then next ಸೊ ಈಗ ನಮಗೆ ಎನ್ನು ಏನಾಗಿದ್ರೆ ಆನ್ಸರು ವಿ ಆರ್ ಗೆಟಿಂಗ್ 15 ಅಂತ ಅಂದರೆ, ಸೊ ಇಫ್ ಎನ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 2 ವಿ ವಿಲ್ ನಾಟ್ ಗೆಟ್ 15. ಸೊ ಇಫ್ ಎನ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 3, ಸೊ ಇಫ್ ಯು ವಾಂಟ್ ಯು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ದ ವ್ಯಾಲ್ಯೂ, ಸೊ ದಟ್ ಈಸ್ ಎನ್ ಆಫ್ ಎನ್ ಪ್ಲಸ್ 2 ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 2 ಆಫ್ 2 ಪ್ಲಸ್ 2 ಅಂತ ತಗೊಂಡಾಗ ದಟ್ ವಿಲ್ ಬಿಕಮ್ 8 ಆಗುತ್ತೆ. ಸೊ ಅದೇ ಎನ್ ಪ್ಲೇಸಲ್ಲಿ ಇಫ್ ಯು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ 3ನ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ 3 ಆಫ್ 3 ಪ್ಲಸ್ 2. So 3 plus 2 is 5, 3s are 15. Okay, so that if n is equals to 3, so then we will, the answer is what? We are going to get √15 Bohr magneton. So that where n is equals number of unpaired electrons are 3, we can say. Next question. A white crystalline salt A reacts with a dilute HCl. ಒಂದು ಕ್ರಿಸ್ಟಲೈನ್ ಸಾಲ್ಟು ಲೆಟ್ ಇಟ್ ಬಿ ಎ ಅಂತ. ಸೊ ದಟ್ ಎ ಈಸ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ವಾಟ್ ಡೈಲ್ಯೂಟ್ HCl ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಟು ಲಿಬರೇಟ್ ಎ ಸಫೋಕೇಟಿಂಗ್ ಗ್ಯಾಸ್ ಬಿ. ಸೊ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ವಾಟ್ ಸಿ ಎ ಈಸ್ ರಿಯಾಕ್ಟ್ ವಿತ್ ಡೈಲ್ಯೂಟ್ HCl. So it is going to liberate what gas B. Okay, and also forms a LOPPT, and also LOPPT is going to form. The gas B turns potassium dichromate acidified with ಡೈಲ್ಯೂಟ್ H2SO4. ಮತ್ತೆ ಈ ಗ್ಯಾಸ್ ಏನು ಮಾಡ್ತಿದೆ, ಬಿ ಗ್ಯಾಸು ಪೊಟ್ಯಾಷಿಯಂ ಡೈಕ್ರೋಮೇಟ್ ಜೊತೆ ರಿಯಾಕ್ಷನ್ ಆದಾಗ ಅಸಿಡಿಫೈಡ್ ವಿತ್ ಡೈಲ್ಯೂಟ್ H2SO4 ಟು ಗಿವ್ ಗ್ರೀನ್ ಕಲರ್ಡ್ ಸೊಲ್ಯೂಷನ್ ಅನ್ನು ಕೊಡ್ತಾ ಇದೆ. ಹಾಗಾದರೆ ಇಲ್ಲಿ ವಾಟ್ ಈಸ್ ಸಿ, ಎ, ಬಿ ಆ್ಯಂಡ್ ಸಿ ರೆಸ್ಪೆಕ್ಟಿವ್ಲಿ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಹಿಯರ್ ಡೈಲ್ಯೂಟ್ HCl ಡಿಕಂಪೋಸ್ ಆದರೆ ವಿತ್ Na2C when dilute HCl is treated with the sodium thiosulfate, that is Na2S2O3 ಜೊತೆ, let us consider this as a plus 2 moles of HCl will be gives it gives 2 moles of NaCl plus sulfur dioxide plus sulfur plus water is going to form. Okay, so ಇಲ್ಲಿ ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ ಗ್ಯಾಸು ಅಂಡ್ ದಿಸ್ ಸಲ್ಫರ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಫಾರ್ಮ್ ಎ LOPPT ನಮಗೆ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ವೇರ್ ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ ಈಸ್ ನಾವು ಬಿ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ, ವಿಚ್ ಇಸ್ ಸಫೋಕೇಟಿಂಗ್ ಗ್ಯಾಸ್. ಓಕೆ, ಮತ್ತೆ ವೆನ್ ಅಸಿಡಿಫೈಡ್ ಪೊಟ್ಯಾಷಿಯಂ ಡೈಕ್ರೋಮೇಟ್, ಸೊ ದೆನ್ ಕಂಟಿನ್ಯೂಷನ್ ಆಫ್ ದಿಸ್ ಕ್ವಶನ್ ಇಸ್ ವಾಟ್, ವೆನ್ ಪೊಟ್ಯಾಷಿಯಂ ಡೈಕ್ರೋಮೇಟ್ K2Cr2O7 is treated with the sulfuric acid H2SO4 plus 3 moles of sulfur dioxide, it is going to give potassium sulfate K2SO4 plus Cr2SO4 tries plus water. So which is green? So here dichromium sulfate is what? It is a green in color. Green in color. ಸೊ ಹಾಗಾದರೆ ಇಲ್ಲಿ ವಾಟ್ ಈಸ್ ಎ ಬಿ ಆ್ಯಂಡ್ ಸಿ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಹಿಯರ್ ಎ ಈಸ್ Na2S2O3, B is sulfur dioxide and C is what? Cr2SO4 tries. So that the option 2 we have Na2S2O3, a sulfur dioxide, Cr2SO4 tries. Next we have the spin only magnetic moment of Fe+2 ion in Bohr magneton is approximately option 1 4, option B 7, option C 5, option D 6 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಿ ಇಲ್ಲಿ Fe+2 is having the electronic configuration Fe+2. It is having the last valence shell electronic configuration 3d6 4s0. So ಇದರಲ್ಲಿ the number of unpaired electrons present, so that is 4. So n is equals to 4. Number of unpaired electrons present is 4. So then mu is equals to square root of n into n plus 2. So that is equals to square root of 4 into 4 plus 2. So that is equals to square root of 4. 4 plus 2 is 6. That is equals to square root of 24. So then it will become 4.898 Bohr magneton, approximately equals to, we can write 5 Bohr magneton. So that answer is the 5 Bohr magneton. That is option 3 is the right answer. Then after this, next we'll be having which one of the following has a magnetic moment of 1.75 Bohr magneton. So ಕೊಟ್ಟಿರುವಂಥ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವುದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ವ್ಯಾಲ್ಯೂ 1.75 ಬೋರ್ ಮ್ಯಾಗ್ನೆಟಾನ್ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಇಫ್ ಐ ರೈಟ್ ದ ಟೈಟಾನಿಯಂ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನು, ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಲಾಸ್ಟ್ ಕಾನ್ಫಿಗರೇಷನ್ 3d1 4s0. Okay, so then vanadium plus 3, 3d2 4s0. Chromium plus 3 will be having 3d3 4s0. Then iron plus 3 we will be having 3d5 4s0. So where number of electrons, n is equals to, here 1 we have, n is equals to 2, n is equals to 3, n is equals to 5. So in order to calculate the magnetic moment, we have the formula mu is equals to square root of n into n plus 2. See, if we calculate for all the options magnetic moment value, so we'll be having for first one mu is equals to 1.73 Bohr magneton we are getting. Second option we are getting mu is equals to 2.83 Bohr magneton, and option 3 is mu is equals to 3.87 Bohr magneton, and option 4 we have mu is equals to 5.92 Bohr magneton will be having. So ಈಗ which one of the following has a magnetic moment of 1.75 Bohr magneton andre titanium plus 3. Okay, so that option 1 is the right answer. Next question. The spin only magnetic moment of nickel plus 2 in aqueous solution would be atomic number of nickel equals 28 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಈಗ the spin only magnetic moment that is equals to mu is equals to square root of n into n plus 2 Bohr magneton. Okay, so where n is equals to the number of unpaired electron. So according to this ನಮಗೆ ನಿಕ್ಕಲ್ 28 ಇರೋದ್ರಿಂದ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ದಟ್ ಈಸ್ ನಿಕ್ಕಲ್ ಪ್ಲಸ್ 2 ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ದ ಔಟರ್ ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ನು 3d8 4s0 ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಡಿ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರೆ ಸೊ 1 2 3 4 5 6 7 8 ಆಯಿತು. ಸೊ n is equals to 2. ಸೊ that mu is equals to square root of 2 into 2 plus 2. So that is equals to square root of 2 into 4. That is equals to 8. Okay, so root 8 Bohr magneton is the answer. So we have root 8 in option 4, so that option 1 is the right, option 4 is the right answer. Next question. Silver iodide is used for producing artificial rain because silver iodide is option 1, it is easy to spray at high altitude. Option B, it is easy to synthesize. Option C, it has crystal structure similar to ice. Option D, it is insoluble in water. We have, okay, so here the answer is it has a crystal structure similar to ice. So if we come to the silver iodide structure, it is similar to ice ಆಗಿರೋದ್ರಿಂದ, so we can silver iodide is used for producing artificial rain. Okay, so we can choose option 3 is the right answer. Next question. Which one of the following shows highest magnetic moment? So ಈಗ Fe2 plus configuration will be having 3d6 4s0. CO2 plus will be having 3d7 4s0. Chromium plus 3 will be having 3d3 4s0. And nickel plus 2 will be having what? 3d8 4s0. 3d8 4s0. Okay, so ಇಲ್ಲಿ number of unpaired electron will be 4 and here n is equals to 3. Here also n is equals to 3 and here n is equals to 2. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲಿದೆ Fe2 ಪ್ಲಸ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಸಹ Fe2 ಪ್ಲಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಇಫ್ ಯು ವಾಂಟ್ ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಬೈ ಯೂಸಿಂಗ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. ಮ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ n ಇಂಟು n ಪ್ಲಸ್ 2 ಬೋರ್ ಮ್ಯಾಗ್ನೆಟಾನ್. Okay, so you substitute in place of n all the number of unpaired electrons for each option. You just calculate it. So that iron will be Fe2 plus will be having the highest magnetic moment value. Next, in a transition series with the increase in atomic number, the paramagnetism is. ಸೊ ಟ್ರಾನ್ಸಿಷನ್ ಸೀರೀಸಲ್ಲಿ ಅಟಾಮಿಕ್ ನಂಬರ್ ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಸಮು ಯಾವ ರೀತಿ ಚೇಂಜ್ ಆಗುತ್ತೆ? ಸೊ ಆಪ್ಷನ್ 1 ವಿ ಹ್ಯಾವ್ ಇನ್ಕ್ರೀಸಸ್ ಗ್ರ್ಯಾಜುವಲಿ. ಆಪ್ಷನ್ 2 ವಿ ಹ್ಯಾವ್ ಡಿಕ್ರೀಸಸ್ ಗ್ರ್ಯಾಜುವಲಿ. ಆಪ್ಷನ್ ಸಿ ವಿ ಹ್ಯಾವ್ ಫಸ್ಟ್ ಇನ್ಕ್ರೀಸಸ್ to a maximum and then decreases. Option D we have first decreases to a minimum and then increases ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಟ್ರಾನ್ಸಿಷನ್ ಸೀರೀಸು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಸಮ್, ಓಕೆ, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಏನಿದೆ, paramagnetism property increases due to increase in number of unpaired electrons. So as of the number of unpaired electrons increases, paramagnetism property also increases. So beyond chromium, number of unpaired electrons decreases, so paramagnetism decreases ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಓಕೆ, ಸೊ ಇಲ್ಲಿ paramagnetism increases due to increase in the number of unpaired electrons. Then beyond chromium ಏನಾಗುತ್ತೆ? ಸೊ paramagnetism property number of unpaired electrons decrease ಆಗೋದ್ರಿಂದ paramagnetism property also decreases. Okay, so beyond chromium number of unpaired electrons decreases, so paramagnetism decreases. So that we can choose option C. First to increase ಆಗುತ್ತೆ to a maximum and then decreases. So that we can choose option 3 is the right answer. Next question. The IUPAC name of the complex ion formed when gold dissolves in aqua regia is. ಸೊ ಗೋಲ್ಡು ಅಕ್ವಾ ರಿಜಿಯಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಆದಾಗ IUPAC ನೇಮ್ ಆಫ್ ದಟ್ ಕಾಂಪೌಂಡು ಏನಾಗುತ್ತೆ ಅಂತ. ಸೊ ಇಟ್ ಗಿವ್ಸ್ ವೆನ್ ಗೋಲ್ಡ್ ಇಸ್ ಡಿಸಾಲ್ವ್ ವಿತ್ ಗೋಲ್ಡು ಅಕ್ವಾ ರಿಜಿಯಾ. dissolve ಆದರೆ we'll be getting the product tetrachloridoorate. Tetrachloridoorate 3 orate 3 anion. Okay, so ಇಲ್ಲಿ when 2 moles of gold is combined with 3 moles of HNO3 plus 11 moles of HCl. So this combination we call it as aqua regia. It is going to give 2 moles of HAuCl4 plus 3ONOCl 3NOCl plus 6 moles of water will be getting. Okay, so then here what is the IUPAC name of that product ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ tetrachloridoorate 2 orate 3. So option 1 is the right answer. Tetrachloridoorate 3 oxidation state will become 3. Option 1 is the right answer. Next question, which one of these is not noun? CuCl2, CuI2, CuF2, then CuBr2. So all copper halides are known except CuI2. Okay, so except what? CuI2. CuI2, which rapidly decomposes, because which rapidly decomposes to cuprous iodide. So that is Cu2I2 and I2. Okay, so 2Cu2I2 will gives Cu2I2 plus I2. So that remaining all other options are known iodides, known halides except CuI2, because it immediately decomposes to the cuprous iodide. Then next, the correct statement is, the first one we have, the earlier members of the lanthanide series resemble calcium in their chemical properties. The earlier members of lanthanide series ಏನಿದೆ ಅದು ಕ್ಯಾಲ್ಶಿಯಂನ ರಿಸೆಂಬಲ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Then second option we have, the extent of actinide contraction is almost the same as lanthanide contraction ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ, is almost same as lanthanide contraction. Then option 3 we have, in general lanthanides and actinides do not show variable oxidation states ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Then in option 4, cerium plus 4 in aqueous solution is not known ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Okay, so that in this we can choose option 1. So that is remaining all other options are wrong. So the extent of actinide contraction is almost the same as a lanthanide contraction. Then option 3 and option 4 are not correct, but option 1 is the earlier members of lanthanide series ಏನಿದೆ, so that will resemble the properties of calcium ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ, that is the chemical properties. So that yes, it is true. So we can choose option 1 is the right answer. Next question we have, so here M. Okay, so this is metal sulfate is treated with NH4OH. It is going to give the product X, and again when that X is treated with the ammonium hydroxide in excess of white, it is going to give the product Y. Then excess of ammonium hydroxide, it is going to give the product Y. Then Y is treated with H2S, we are going to get the product Z. Here what is X, Y, Z and M they are asking. Okay, so ಈಗ MSO4 in place of metal, if we consider zinc sulfate, where M is equals to zinc ತಗೊಂಡ್ರೆ, so zinc sulfate is going to give in the presence of ammonium hydroxide, it is going to give the product zinc hydroxide. Zinc hydroxide is going to form. Okay, so which is white in color. Then again, when zinc hydroxide is treated with a NH4OH, one more mole of NH4OH, excess of ammonium hydroxide if we add, so that will become clear solution. The solution will become what? Clear. So here if we write this is as X and this one is as Y, then again for clear solution, if we add pass H2S gas, so we'll be getting the product zinc sulfide. Okay, zinc sulfide barutte, which is represented as Z. Okay, so where M is the zinc metal, Z is zinc sulfide, and X is zinc hydroxide, and Y is clear solution. So here the M and Z are ಏನಾಗಿರುತ್ತೆ zinc and zinc sulfide ಆಗಿದೆ. Okay, so that option 1 we can choose, it is the right answer, zinc and zinc sulfide. Then next question we have the option D, we have xenon 4f7 5d1 6s2. Okay, so in that the electronic configuration of GD2 plus A is option B, xenon 4f7 5d1 is the correct option for the electronic configuration of GD plus 2. Next question. The bivalent metal ion having maximum paramagnetic behavior among the first transition series element is the bivalent Yes, the bivalent metal ion having maximum paramagnetic behavior among the first transition series element is, so which bivalent metal ion will be having the maximum paramagnetic property, that we need to know. So here the first option will be given, like Mn plus 2 is given. If we write the electronic configuration for that, no, so we'll be having last valence electronic configuration 3d5 4s0. So where n is equals to number of unpaired electrons of 5. Then if we write the configuration for Cu plus 2, so we'll be having 3d9 4s0. Okay, so we'll be having the number of unpaired electrons of 1, and scandium plus 3 we have. So 3d1 4s0 we have. So then it will becomes n is equals to 1. Then Cu plus 3d10 4s0. This is completely filled orbital. So that will gives n is equals to 0. Okay, so unpaired electrons will be 5 1 1 0, like that we have, where Mn2 plus will be having maximum oxidation state, so that it is having the maximum paramagnetic property, we can say. The elements which are having the maximum oxidation state, that can show the maximum paramagnetic behavior, so that we can choose option 1 is the right answer, that is Mn2 plus is the right answer. Next, on heating potassium permanganate, one of the following compound is not obtained. So potassium permanganate na heat ಮಾಡಿದ್ರೆ ಕೊಟ್ಟಿರೋಂಥ options we have MnO, O2, K2MnO and MnO. So which compound is not going to form ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. So when we heat potassium permanganate KMnO4, 2 moles of KMnO4 is heated. Okay, so we'll be getting K2MnO4 plus MnO2 plus O2 is going to form K2. So this is MnO2. So this is K2MnO4. Okay. So which here will be having K2MnO4 is the product side only, and MnO2 we have and O2 we have, except MnO. All the options are second, third and fourth options products are formed as a product, but MnO is not the product. When we heat the potassium permanganate, will not getting the manganese oxide, so that we can choose option 1 is the right answer for this. Next question. The bivalent metal ion having maximum paramagnetic behavior among the first transition series element is. So here Mn2 plus we have, which is having the configuration last valence electronic configuration is 3d5 4s0. Then Cu2 plus we have 3d9 4s0. Then scandium, that is we have 3d1 4s0, and Cu plus we have 3d10 4s0. Okay, so where n is equals to 5, n is equals to 4, here n is equals to 1, and here n is equals to 0 we have. Okay, so yava element having the maximum number of unpaired electrons, that is going to show the maximum paramagnetic behavior. Okay, so that we can choose Mn2 plus will be having the maximum paramagnetic behavior. Maximum paramagnetic behavior. Okay. Then next we have next question. When a brown compound of Mn, let it be A, is treated with a HCl, it gives a gas B. The gas B taken in excess reacts with NH3 to give an explosive compound C. The compound A, B, C are. So what is the question? A brown compound of Mn. So that is when A is Mn anta ಹೇಳ್ತಿದ್ದಾರೆ. So when Mn brown form ಅಲ್ಲಿ ಇರುತ್ತೆ and it is going to treat with what? HCl ಜೊತೆ treat ಆದ್ರೆ, so that is going to give the gas B. ಮತ್ತೆ again this B is treated with the excess NH3. We are going to get the product what? C ಬರುತ್ತೆ. Then what is A, B, C ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. Okay, brown color form of Mn compound ಯಾವುದು ಅಂತ ಅಂದ್ರೆ, so that is MnO2. Okay, so MnO2. So let us consider this as A. When it is treated with the 4 moles of HCl, it is going to give Cl2 plus MnCl2 plus 2 moles of water is going to form. Okay, so where Cl2 will considered as a B anta consider madana. Matte when 3 moles of Cl2, so when 3 moles of Cl2 is treated with the NH3, so excess NH3 ಜೊತೆ treat ಆದ್ರೆ will be getting NCl3. Mn is treated with HCl and that product is undergoes the reaction with the excess of NHO3. Explosive compound is going to form, so that is trichloronitride. Okay, so this is very explosive in nature. So where A is what here? MnO2. So here we have in option 1 A is equals to MnO2, then B is what here? Cl2, B is Cl2, and C is NCl3. C is what? NCl3. So option 1 is the right answer. Option 1 is what? Right answer. Next we have next question. Mn2 plus compounds are more stable than Fe2 plus. Mn2 plus compounds are more stable than what? Fe2 plus. Mn2 plus compounds are more stable than Fe2 plus compounds towards oxidation to their plus 3 state because. So Mn2 plus compounds ಎಲ್ಲ more stable than Fe2 plus compounds ಆಗಿರುತ್ತೆ towards oxidation to their plus 3 state. ಯಾಕೆ ಅಂತ ಅಂದ್ರೆ first option we have Mn2 plus is more stable with high third ionization energy. Option B, Mn2 plus has completely filled d orbitals. Option C, we have Mn2 plus does not exist. And option D, we have Mn2 plus is a bigger in size ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay, so ಇಲ್ಲಿ usually Mn2 plus has stable off-filled electronic configuration. So Mn2 plus which is having the stable off-filled electronic configuration, so that it has high IE3. Okay, so third ionization energy, while Fe2 plus on losing one more electron will acquire this stable electronic configuration. So thus Fe plus 2 is more prone to get oxidized to +3 oxidation state. Okay, so ಇಲ್ಲಿ Mn2 plus initially it is having the more stable off-filled electronic configuration ಇರುತ್ತೆ, so that it has third ionization energy. But if we come to the Fe2 plus, on losing one more electron will acquire this stable ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಕಳ್ಕೊಂಡಾಗ ಮಾತ್ರ it is going to acquire what? The stable electronic configuration, so that Fe2 plus is more prone to get oxidized to Fe plus 3 oxidation state. Okay, so that we can choose option 1 is the right answer. So ಯಾಕೆ ನಮಗೆ Mn plus 2 compounds are more stable than that of the Fe2 plus ಅಂತ ಅಂದ್ರೆ Mn2 plus is more stable with a high third ionization energy ಆಗಿರುತ್ತೆ. So that next question, which of the following statements in wrong regarding lanthanides? ಸೊ ಲ್ಯಾಂಥನೈಡ್ಸ್ ರಿಲೇಟೆಡ್ ಕೊಟ್ಟಿರುವಂಥ ಫಾಲೋಯಿಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸು ಯಾವುದು ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗಿರುತ್ತೆ ಅಂದರೆ, lanthanum plus 3 compounds are predominantly ionic character. Lanthanum plus 3 hydroxides are mainly basic in nature. Then third option is the ionic size of lanthanum plus 3 ions decreases with increase in atomic number. Then lanthanum plus 3 compounds are generally colorless ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay, so ಈಗ ಇಲ್ಲಿ many of the trivalent ions of lanthanides are colored. In nature or colored. Okay, both in solid state as well as in solution state. Okay, so the color of the lanthanide ions arises. So ಯಾವಾಗ ಸೊಲ್ಯೂಷನ್ ಕಲರ್ ಬರುತ್ತೆ ಅಂದರೆ, ಬಿಕಾಸ್ ಆಫ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದ lanthanides in that solution. Okay, so ಆಗ when the whatever the electrons are present in that lanthanides, no, so that will jumps from lower energy level to the higher energy, and while coming back to the lower energy it will absorb some amount of light from the visible region. Okay, so visible region ಅಲ್ಲಿ light ಅನ್ನು absorb ಮಾಡಿಕೊಂಡು, so it is going to form a FF transition, as lanthanide have partly filled F orbitals. FF transition possibility ಆಗುವಂಥ ಚಾನ್ಸಸ್ ಇರೋದ್ರಿಂದ, ಸೊ lanthanum plus 3 compounds are generally colorless ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಬಟ್ ಇಫ್ ವಿ ಕಮ್ ಟು ದ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಬಂದಾಗ they'll give the color property because of its DD transition. So ಇಲ್ಲಿ ಬಂದಾಗ, so the electrons will jumps from lower energy to the higher energy, and the color of the lanthanide ion arises due to the absorption of light from the visible region of spectrum, resulting a FF transition, as lanthanides have partly filled F orbitals. Partially ಎಫ್ ಆರ್ಬಿಟಲ್ಸ್ ಅಲ್ಲಿ ಪಾರ್ಟ್ಲಿ ಫಿಲ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರೋದ್ರಿಂದ ಸೊ ಲ್ಯಾಂಥನಮ್ +3 ಕಾಂಪೌಂಡ್ಸ್ ಆರ್ ಜನರಲಿ ಕಲರ್ಲೆಸ್ ಆಗಿರುತ್ತೆ ಅಂಡ್ ರಿಮೈನಿಂಗ್ ಆಲ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಆರ್ ಕರೆಕ್ಟ್ ರಿಲೇಟೆಡ್ ಟು ದ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ಆಪ್ಷನ್ 1 ವಿ ಹ್ಯಾವ್ ಲ್ಯಾಂಥನೈಡ್ ಕಾಂಪೌಂಡ್ಸ್ ಆರ್ ಪ್ರಿಡಾಮಿನೆಂಟ್ಲಿ ಅಯೋನಿಕ್ ಇನ್ ನೇಚರ್ ಆಗಿರುತ್ತೆ. ಆಪ್ಷನ್ ಬಿ ಲ್ಯಾಂಥನಮ್ +3 hydroxides are mainly basic in nature irutte. Then option C, ionic size of lanthanum +3 ion decreases with increase in atomic number. So option D is the wrong statement related to the lanthanide, so that we can choose option D is the right answer. Okay, option D is the right answer. Next question, which of the following is an amphoteric oxide? ಸೊ ಆಂಫೋಟೆರಿಕ್ ಆಕ್ಸೈಡ್ ಕೊಟ್ಟಿರುವಂಥ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ವಿಚ್ ಒನ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಇಸ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಎ ಆಂಫೋಟೆರಿಕ್ ಆಕ್ಸೈಡ್ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಆಂಫೋಟೆರಿಕ್, ಫಸ್ಟ್ಲಿ ವಿಲ್ ನೋ ವಾಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಆಂಫೋಟೆರಿಕ್ ಆಕ್ಸೈಡ್. So amphoteric oxides means oxides that act as either an acid or base in a reaction to produce salt and water. Okay, so this we call it as what? Amphoteric oxides anta heltivi. So here we have first option is vanadium pentoxide and chromium oxide. So where V2O5 is amphoteric in nature. Next Cr2O3 also amphoteric. Cr2O3 also amphoteric in nature. Then if we come to Mn2O7 ಏನಿದೆ, so this is actually, it is not amphoteric, it will act as only the acid. Okay, so this is acidic in nature, we can say acidic in nature. Then CRO, it's there na, that is basic in nature. CRO is basic in nature. Then one more we have, that is V2O4, that is basic in nature. V2O4 is what? Basic in nature. So V2O5 is amphoteric, it is amphoteric in nature. CrO3 also amphoteric in nature. Mn2O7 also acidic in nature. Then CRO also basic in nature, and V2O4 is basic in nature. Here which of the following is not an amphoteric oxide ಅಂತ ಕೇಳ್ತಿರೋದ್ರಿಂದ ಆಪ್ಷನ್ ಎ ಏನಿದೆ, ಸೊ ಆಪ್ಷನ್ ಎ following is an amphoteric oxide. Option A ಅಲ್ಲಿರುವಂಥ V2O5, then Cr2O3. So this is Cr2O3. Okay, Cr2O3. So these two are in amphoteric in nature. Then if we come to option B, here we are having Mn2O7 and Cr2O3. Correct? No, here Mn2O7 is not amphoteric in nature, it is acidic in nature, but Cr2O3 is amphoteric in nature. Then option C we have CRO, it is basic in nature, but V2O5 is amphoteric in nature. Then option D we have V2O4, then V2O5 is amphoteric in nature and V2O4 is basic in nature ಆಗಿರೋದ್ರಿಂದ, so the pairs which are given in the options which shows the amphoteric oxides ಯಾವುದು ಅಂತ ಅಂದರೆ we can give option A ಅಲ್ಲಿರುವಂಥ both the choices are amphoteric oxides, so that we can choose option 1 is the right answer. So with this we completed the D and F block elements related previously here solved all the level questions. So in next class we will continue with a new chapter. So for more videos visit Takshara Academy website.